Hello students, welcome to our educational channel PAATHSHALA Pandit. I am Ayus Bhattacharya. In this channel, we will discuss all the academics related to maths and science. If you feel this video is really helpful, please like it, share it with your friends, and also do not forget to subscribe to our channel. Also, if you have any doubt, please post it in the comment section. I will reply to it. Thank you very much. Hello students, today we will learn about gravitation. First, let us know who discovered gravity. We all know that it is Isaac Newton. We all know the story behind it. An apple fell on the head of Isaac Newton when he was young, and then he kept on thinking that why this apple fell on my head in this vertical direction, and by thinking and thinking he discovered gravity. He also thought that maybe this is the force that holds the planets in a particular orbit. Okay, so this is how gravity is discovered. All right. Now, before we learn the details of gravity, let us first see a few more concepts. Let us see what is centripetal force. Centripetal force. All right. Now, take an example of a stone tied to a string. Okay. So now you have to hold the string at the other end and rotate it as fast as you can. Rotate it fast like this. By doing this, what will happen? You will feel a force on your fingers. Like when you rotate it very fast, you will feel that the stone will just come out of your hand or of the string will break. You will feel like that, but still you will apply a force, you will hold on to it, and the stone will not fall. So the force you are applying on the stone to keep it in circular motion, because you are holding it, right? So the force you are applying now on the stone so that it doesn't move out and keeps on rotating in a circular orbit is known as centripetal force. Okay. Now let me write the proper definition. A force acting on an object moving along a circle and is directed towards the center of the circle is called centripetal force. Like I give the example, so let me draw it here also. Okay, so consider this as a circle. It's a bit of an oval shaped, but imagine it. So now we were tying perhaps the stone is here, means consider the stone to be at this point at this instant, and this is my hand. All right, and this is the thin string. So it is going like this, I mean rotating or revolving like this, so acting on an object moving along a circle, and so I am acting a force on it, just as I said that I have to pull the stone with the string so that it doesn't get thrown out. Okay, so I am pulling it like this. This is my hand, this is the stone. Force will act in this direction. This is the force, centripetal force along a circle, because it is a circle, so obviously, and is directed towards the center of the circle is called centripetal force. All right, so this is the centripetal force we are studying right now. Now I am talking about another property, so pay attention to it. Suppose by rotating the string in such a speed that the string actually gets broken off. Okay, So then what will happen? Consider the string broke at this point only. It was rotating and broke here. Now the stone will fly off. What will happen? The stone will fly in a tangential direction. In a tangential direction, like this. See, this is a tangent, okay? This is a tangent, okay, of this whole circle. When it breaks at this point, the stone will fly in a tangential direction because the direction of the stone at this point in time is here in this tangent. Suppose the stone is here and breaks off at this point, then it will fly off like this, okay? Suppose it is here, it will fly off like this. So you can see, we know what is a tangent, right? A line touching a circle, that is a tangent, of course. So the direction of the stone at any point in time when revolving in a circle is tangential to the circle at that point. Here the tangent is this, so direction is this, direction is this, direction is this. And when the string is cut or string broken off, it will fly off in this direction only. It will not go like this or like this. No, these are wrong. It will fly in a tangential direction. So remember this. This is the direction. I am writing it short, direction, and this is the force. Alright. Now let us see Kepler's laws. Kepler's laws. So Kepler, the full name is Johannes Kepler, okay? Johannes Kepler. Let me write it that. Kepler. So he gave 3 laws. About what? About planetary motion. The planets revolving around the sun, they don't revolve anyhow. They have a fixed pattern. So about that pattern he gave 3 laws. What are those laws? We will see. The first law is, I am writing it like this. First law, let me write the statement. The first law says the orbit of a planet is an ellipse with the sun at one of the foci. Now let's understand the statement first. I am drawing an ellipse. What is an ellipse? It is basically an oval, okay? It is basically an oval shaped. Now I am drawing it freehand, so it will not be exactly an ellipse, but still, okay, it is an ellipse, imagine it, an oval shape. So consider, a cone, means a birthday cone, a birthday hat type, it is a cone. So if you cut this cone like this, means you have to cut it like this, okay, just like that, in an inclined manner, then the shape you will get on the face of the cone will be like this, oval shaped or elliptical. So you got an idea about ellipse. Also another thing, you have to remember what is foci. Foci means what? Suppose this is, okay, well, let me draw another ellipse actually. See, this is another ellipse. Now if we draw these, okay, these lines, they are perpendicular to each other, okay, perpendicular to each other, and cutting it in 4 equal pieces. So here a point will come, here also a point will come. Now from this point, and suppose I take a point like this, then if I draw a line like this and like this, okay, then suppose this is, with the blue marker I drew a line, it is of suppose 1 meter. Then with black marker I choose this point and drew these lines. Then the total length of these lines, this line plus this line, is also 1 meter. Suppose I take another point, any point, any point, but on the edge only, okay, not inside or outside. So if I take suppose this point, okay, if I take this point and also I join these 2 points, these 2 lines I joined, and the total length of this line will also be 1 meter. Means, you see, take any point, draw lines from the 2 foci. This is a foci, means this is a point, okay, for now consider it as point, and then if the lengths become equal only, here I take a point, join a line, join 2 lines, and the length comes out to be same everywhere, then this point and this point are known as foci. If one point is done, then focus, 2 points or means more than 1 points, then foci. That is why these points are known as foci, because we just saw, because the lengths are equal. Okay, so let me rub this example. So the orbit of a planet is an ellipse. First thing you must know, it is not a perfectly circle, it is elliptical in shape. So that thing is clear, elliptical in shape, with the sun at one of the foci. Now the sun, okay, let me draw the sun with red. This is the sun, alright, nice big sun. It is a point where the focus lies, okay, the ellipse focus is here. Sun will be at this point only, it cannot be here, it cannot be here, of course not here, at the focus only. Then, well, this is the first law actually, with the sun at one of the foci. Okay, alright. Now see, let's talk about the second law. The second law says the line joining the planet and the sun sweeps equal areas in equal intervals of time. Let us see what it exactly means. Okay, so here in this diagram I have of course drawn an ellipse because that is the orbit, sun, earth, this is the earth, okay, consider it as earth. Now suppose in 1 month, or wait, first let me explain you how it actually revolves. Okay, see, you might think till now that the planets revolve like this with a constant speed, but that is not the reality. The reality is it will revolve somewhat like this, okay, slow here, as it approaches fast, very fast, slow, very fast, slow, fast, slow, fast, slow, slower, slowest, fastest. Okay, this is how it actually revolves. Suppose in 1 month, take 1 month as an example, it goes from this point to this point. Okay, in 1 month it went from point A to B. Okay, so now join a line. join straight lines. Alright, and here this area we got, take it as S. Okay, S for sun. So this area SBA, okay, area is BA, SBA. Now in 1 month it goes, here it is slow, so it goes from A to B only. Now it comes till here, okay, this is point C. Now do you think that this distance will be covered here in 1 month? Here only it will stop in 1 month? No, just as I said, here the speed is greater, so it will cover much more, means almost till here it will cover. The speed is great, so it will create greater distance in 1 month. So take it as D. This is wrong, this is not the case. Again join the lines. Okay, now what Kepler said in its second law, that line joining the planet and the sun, line joining planet and the sun sweeps equal areas in equal intervals of time. We take equal intervals of time, 1 month only. So in 1 month it will go from A to B, and the line joining will go from here to here, SA to SB. So this area, and here it is SC to SD, this area. So area SBA is equals to area SCD. This is what Kepler said in his second law, that it will, in 1 month it will cover this much area. In 1 month, here if it reaches, it will cover this much area. But whatever be the speed, areas will be equal. Okay, areas will be equal. Suppose it is right now in a mid position, so it will cover equal areas only, and it will go from here to here perhaps. Okay, is equals to, suppose take it as E, and this is F. So area SEF. Areas will be same if the time interval is same. Okay, this is second law. Let's see the third law. Let's see what the third law says. The square of its period of revolution, it means a planet's period of revolution around the sun, is directly proportional to the cube of the mean distance of a planet from the sun. In simple word, it means T squared directly proportional to R cube. So what is T? T is time period of the revolution. The whole revolution means for Earth it is 1 year. For Mercury, the planet Mercury, it is 84 days. So T squared, that T is, we have to square it, is directly proportional to R cube. Now what is R? The mean distance between sun and the planet. See, this is also a distance, this is also a distance, this is also a distance, SB, SA is also a distance, but we have to consider only one distance. So we take all the distances, take an average out of it, then that distance is known as the mean distance. So R is that mean distance, and we have to cube it. Then that is what the third law says. So if we want to remove this alpha sign or the proportionality sign, what we need to do is T square by R cube is equal to K. K is a constant, you all know that, means any constant of proportionality. So these are the three of the Kepler's laws. Now he didn't actually give any explanation why the first law, second law and third law is true. No scientific explanation was given. Later Newton came and gave proper mathematical explanations to this and proved that all three are true. So I hope you liked this video. Thank you very much.